Hello. This is a talk about the trust execution environment, the past that brought us to the current place we are at, and the future where it may be going. My name is Don Felton. I'm a Principal Security Architect at Trustonic, and I have been Chair of the Global TEE Platform Specification Working Group, defining the functionality and architecture for TEs for many years. The reason for this talk is that I'm in retirement, and so we're trying to provide some history. So let's start. What is a TE? A TE is an area of a device that is considered secure. It's isolated from the rest of the device and trusted by the users of that environment that it creates. As such, it provides protection from attacks generated in the rest of the device, and even provides protection against other actors inside the TE. So a TE typically will be running applications that are installed into it, and there is protection in the TE such that one application is not able to interfere with others. The term TE is seen as generally a good definition of device security. So while it may have originally been defined for particular use cases, it is now being used in many places beyond that original definition. The original definition came out of a group called the Open Mobile Terminal Platform, and I'll talk a bit more about that in the future. And the global platform efforts in TE are based on that original OMTP functionality and security principles. So basically, to enable that following those principles, Global Platform has defined protection profiles, and these enforce and allow labs to validate the security of the TE. And the GP has defined configurations which allow third-party labs to come along and validate the functionality of a TE. And with the independent validation of the security and the functionality, the GPT is designed to provide consistency for users. It should be clear that the global platform TE isn't locked to a specific type of CPU. It's not locked to a specific type of hardware architecture. Its history is based on a particular capability set, but the requirements to be a GPTE are purely requirements in terms of isolation and functionality, and are not requirements that should be forced upon any particular hardware solution. So where did TEs come from? So TEs really started out with Nokia when they were the big player in the mobile phone space, and they had a desire for a security environment built into the devices. They'd seen the validity and the usefulness of SIMs, the operator-bound modules, and they felt that that was useful, but as a manufacturer, as an OEM, they wanted something that was attached into the device rather than into the more general, into something that was removable. If it's removable, it didn't allow them to provide the security needs that they desired. So they could see three different solutions to meeting that goal, providing that independent security environment bound into the device. They could create another chip that they would solder onto the PCB, and that would provide that secure functionality. That's quite an expensive thing to do when you're making millions of devices. They could create a isolated subsystem inside the system on chip. So, I hope we're familiar in the audience that devices these days generally look at having a single chip that provides not just the processing power, but also a lot of the other functionality. And so all the system that used to be on a PCB is now, as far as possible, bound into one chip. And so rather than having a separate chip on the PCB providing the secure environment, they could have done a separate environment inside a separate CPU and a separate bit of RAM and a separate bit of flash controller or something inside the general system on chip silicon. And that would have been another solution, but again, it was quite an expensive solution in terms of design effort and other aspects. And a third space that would have provided them a separate environment running inside the same processor structure on the silicon would have been to use hypervisors. But hypervisors have a vulnerability. They at the time certainly were uh, open to having the JTAG hardware debug used to look at what they were doing. And so they didn't provide isolation in terms of things like JTAG viewing them. And they also were vulnerable to other components on the SOC. An example of this was that one of the operating system vendors at the time quite recently had very good operating system security, but one of the things it allowed a application in our operating system to do was to move the location of the video display buffer. And so point the video display chip at different locations. And someone immediately pointed the video display buffer at where the keys for that operating system were held, and therefore they were then displayed in terms of colors on the screen. But in terms of colors, gives the attacker a very good idea of what was happening. So you can't just look at isolation from the point of view of what an operating system might do at one level. You've always got to consider what other hardware components on the device might do. And so hypervisors were a bit on the edge for not being able to protect against those sorts of attacks. And fundamentally, in around 2003, 2004, Nokia approached ARM through their silicon vendors and said that they'd like something to solve this problem set. And ARM came up with basically what is a better hypervisor. It's a very specialized hypervisor, but a hypervisor where certain hardware states are also changed to protect against these sort of attacks. And that gave an interesting environment to which we could then work forward in the future. And so we got the first TEs. And the first standards group that looked at TEs was this organization I just called OMTP. And that's the Open Mobile Terminal Platform, which was basically an organization of operators, mobile network operators. Now, I've just said that the OEMs were the people who were interested in the TE technology because they wanted a secure, separate space on the device which would allow them to do things independently of the operating systems on the device in a secure, isolated manner. And yet the first active standardization work that kicked in was from the operators. And the reason the operators were interested in this and were interested in standards in this place is that they weren't looking at dealing with one mobile phone with one operating system on. They were trying to deal with many mobile phones with many operating systems at that time. And they wanted somewhere that provided them some consistency. And also it appeared to provide them a very good place to solve one of their other big problems, which is related to subsidies, because it's a SIM that is the operator presence on the mobile phone, and yet the operators have bought and subsidized the phones. And what happens is the attacker comes along and he cleverly takes the SIM out of the mobile phone and throws it in the bin. Okay, now we don't have any operator presence on that phone that can't be overridden because it's in the regular OS, and at which point the operators lose control of things like the fact that they've subsidized the phones. So they were very keen on the idea that there was some generic but standardized functionality available. And they basically came up with a set of security criteria that needed to be met, and they came up with some very high level functionality criteria. Having done that, that group was at the edge of where it could work. It was basically not set up to go further. And they handed over the future work in this space to an organization called GlobalPlatform. GlobalPlatform had a history of creating standards in the secure element space around passports and banking cards and SIMs and UICCs, which would drive functionality in that space and drive security in that space. So GlobalPlatform already were used to the idea of creating material that third-party labs could validate, and third-party lab validation is the ultimate way of today proving that you did the job right when you created one of these sort of environments. And so they were a natural place to hand the baton on to then go forward and create further standardization, which would drive this desire from the operators that there would be something common that would appear on all devices that they might have an interest in. At the time, that would have been feature phones and early smartphones. You've got to remember this was in the days before iOS and Android had really taken off. And so there was effectively more variety out there, but the use case is still valid. So handing it over to the GlobalPlatform, there was a committee called the Device Committee, and that was put in charge of providing functionality and security standards relating to the TE. The first one that came out of the Device Committee was back in July 2010, and that was a standard for how do you communicate from anywhere else into the TE. That's always a good place to start. If you've got a new environment that does things, let's standardize how the communication interface works. Having done that, then once you can talk to it, it'd be nice to be able to standardize what it can do inside that environment. And the first standard on that came out of Device Committee in December 2011. That standardized capabilities inside which are common to security type operations. So it provides cryptography, it provides memory management and communications, and it provides secure storage. Secure storage in the TE is kind of interesting in as far as it appears to be a little like a simple file system. But the critical thing that it does is that your trusted application, that's the special sorts of application designed to run into a TE, cannot see the file systems of any other trusted application. They basically have a limited view that only allows them to see their own material. And that obviously is quite a big security step because they can't interfere with the other trusted applications or even with the normal with other applications on the device because they have no direct view of the file systems in the general device area. So having created the sort of kernel, the core of capabilities that you might want in a TE, then the committee and the working group proceeded with other areas of interest. So these are things that are being driven by the members who are looking for particular capabilities and functionality out of the TE environment. And the first one of those extra abilities was a pre-configured user interface. So a difference between a TE and some of the other secure systems like an HSM or a secure element is that it's typically built, integrated very heavily into the general system. And so it can do things like isolate the peripherals on a device such that the rest of the device can't interact with them. and therefore there's a security guarantee that can be made about the material that's being displayed. There's no way that you can snoop that material from the rest of the device, or even from another trusted application running in the TE when a particular trusted application is using it. And that's very useful in the display device space for things like PIN entry, password entry, and even document display ultimately. So originally there was a very simple pre-configured user interface that could do PIN entry, password entry, and document display, but wasn't very flexible. You basically had to use a very restricted look and feel that came from that TE. And so that came out in 2013. And then in 2018, there was a more generic user interface provided, which would allow you to basically access a secure frame buffer as a trusted application and do what you liked. So this is something that is an improvement from the product branding point of view, or right, not product, application branding. If you're a bank and you want to have a secure banking app, then you can use this with your particular branding look and feel. Okay, so that's one of the things that was driven by members. Another thing was, well, hey, we're in global platform and there's a lot of interest in interfacing and interacting with secure elements, not just the ones in SIMs, but also the ones being used for NFC communication and other secure purposes. And so in 2014, a specific API was developed for talking to secure elements. And it would also be very nice if you've got this trusted application to be able to securely talk to back-end systems. And so in 2015, a sockets API was created. Something that would allow you to use TCP, UDP, or at that time, TLS 1.2. TCP and UDP, so you can use your own protocol for security if you really want to, and TLS if you want to use TLS. I will say, for those who are aware of the details of that specification, that it was quite limited at the time, but there is a more recent one that's come out in the last year, which is TLS 1.3 capable and doesn't have many of the restrictions of the earlier GP TLS sockets. And then finally in the list, we've got management. So as I've said earlier, there are things called trusted applications which run in the TE. They're designed to make use of the TE capabilities. How do they get there? So initially, the way they got there was the OEM designed some special custom system for injecting trusted applications. And so the mobile network operator or the bank or whatever would have to deal with that particular specific manner for injecting new trusted applications, or even personalizing the data for trusted applications that were installed. So that's not very desirable when we're trying to make something a generic environment. And in 2016, a remote management protocol suite was created that allowed the trusted applications to be injected and managed, and allowed an ownership hierarchy. So, ultimately the device is created by the OEM. So unless someone else is installed in the factory, the OEM is the root owner of the TE. But I'm a bank. I don't really want the OEM to be able to interfere with my applications. And so this management framework would allow the OEM or another authorized party to give further authorization to something like a bank to install their applications and manage their own applications, and without the authorizing party being able to interfere with the ability to install and manage those applications. And this is useful from the point of view of the bank, has assurance that no one will interfere with what they're doing in the way of installing applications and things. And because of the way the trusted execution environment under global platform works, I don't have to worry as the OEM that the bank might do something nasty and try and install an application that interferes with other trusted applications or wider things in the device because of the guarantees that are made under the protection profile that the TE is validated against. Those guarantees say, look, we've been examined and checked and looked at, and there is no way that such interference from a rogue trusted application can interfere with anything other than the rogue trusted application. We're safe. That's a good thing. So we're starting to talk about security. And how does GP enable that security? So the GP basically uses the common criteria standard for defining security, defining the isolation, the attestation, the authentication required under certain circumstances to do certain things, what the assets are and how they are protected. And back in 2013, GP started releasing a protection profile defining how that works for a TE. GP has done it for other things, but this was the TE space. And having defined how the TE protects its assets, the assets being things like the trusted applications that are running inside it, the data of those trusted applications, etc. Then there were some extensions made to cover things like media handling, biometrics, and trusted user interfaces. And so if you are using biometrics which are being protected by a TE, then they should have been validated by a lab to meet these security standards. Beyond that, GP has also provided other material which assists with the security understanding. Some of it's kept private inside GP because it's shared amongst the labs to give them a common reference point, but much of it is also available publicly. And so there are cryptographic algorithm recommendations. Don't use old-fashioned algorithms like MD5. Do use modern algorithms like AES 256. And those actually apply at two levels. There are recommendations for you as a trusted application writer. We can't enforce what you do as a trusted application writer today, but we can make recommendations how you write your applications and try and be helpful that way. And then there are also internal recommendations which drive how the trusted execution environment itself must provide security. And these are recommendations because there are many different ways you might solve the problem, and we're not going to restrict you to one particular solution, but they are looked at by the labs who are evaluating the TEs, and if you are wide of the recommendations, they'll want to see some sort of justification for why you are still secure before they'll issue their rubber stamp to say you did a good job. Okay. And so let's just have a quick look at the development of one particular document in GP to give you an idea that, this is an ongoing thing. None of these things are set in stone. They are being improved over time, and there is active participation from members driving these things forward. So here we're looking at the internal core roadmap, and it came out in 2011. Over the next, well, until today, we have been improving it. Initially, it was very focused on 32-bit computing because that's what was available back in 2011. Over the next 3 or 4 years, there were many clarifications added to it, and some of those were around 32-bit and 64-bit handling. Mainly this comes into the area of buffer sizes, buffer allocation, all that sort of thing, because we've got bigger systems there. We need to at least acknowledge in the functionality requirements that those bigger systems might be handled with bigger interfaces, and so the interfaces need to be enabled in that space. We made some interesting additions in the 2018 v1.2 release. So prior to then, there hadn't been any standardized interfaces for communicating with peripherals. Well, there'd been the trusted user interface, there'd been the sockets interface, there'd been, but these are all very specific, designed around that known subset of functionality. There'd been nothing generic. So 2018, the general internal core API added peripherals and event interfaces. And so that provides a lot of more flexibility to deal with different pieces of hardware that a TE might be installed into. Frankly, the early TEs all ended up in the smartphone space, except for a very small. Oh, actually, that's not true. Okay, a lot of TEs ended up in the smartphone space. Others did end up in different things, broadband routers and watches, but with a pretty specific API need from the hardware point of view, and one which generally either didn't need any extra interfaces or where those interfaces were sufficiently proprietary that there wasn't a need for a generalized capability. But in 1.2, we took the capability set that had sort of been started in the trusted user interface work, and we generalized it further and we put it into the core. So now the core can talk to any hardware that has been connected via an appropriate hardware adaptation layer. 2021 brought some new secure storage types, and the latest work has been adding into the post-quantum space. In the APIs, interfacing to cryptography is done via some namespace allocations, number space allocations. And what's happened here is that we are looking into the future at where post-quantum is going. We're allocating the number space, but we're doing it all as optional. And so if it turns out that one of those post-quantum algorithms isn't particularly good, then that's okay. You don't have to use it. Use one of the other ones. But at least the interfaces are defined so that people can start developing in that space. And the other thing that's been going on recently is that we're back in the hypervisor world. There are more use of hypervisors happening in the general device. And so it's started to become clear that when something is trying to talk to the TE, we need better identification about the thing that's talking. Previously, we could tell the difference between, I don't know, a banking app and a medical app, because those two apps are running in the same operating system, and that operating system would provide some identity which would say that they're different. Now, if I've got the banking app running in the operating system on one hypervisor and the same banking app, for some reason I can't explain, running in a totally different operating system on another on the same hypervisor, the old system wouldn't have been able to tell the difference. So we've introduced a new system that not only tells you that it's the same banking app, but will tell you it's a different operating system. So you'll be able to say, oh, okay, it's the same piece of code, but it's coming from a different place. So maybe I want to treat it differently. So that's the area that's going on at the moment, and that's shows that we've got ongoing efforts, still developing future specifications. And there's a long list of things that we'd like to put in 1.5 that have been asked for by various members to keep improving the functionality of a TE. So let's just now step back a bit and have a look at what else is going on outside the space where the GP membership have been asking for capabilities and functionality. So we see other things out there that are around the TE space, and this is just a small subset of the sort of things that exist. So we've got various efforts in TCG and frankly elsewhere to provide attestation standards. Um, from the TE point of view, those often look like a application running in a TE. There have been TPMs that have basically been pieces of code running in a TPM, running in a TE, providing TPM functionality for the wider world. Great, that's interesting, and an area which TEs support. There's also the whole confidential compute and enclave space. Fundamentally, a TE is sort of a confidential compute environment. It has most of the characteristics of a confidential compute. It provides confidentiality of what you are doing from the general device. It provides, under the GP standards, things that other confidential compute environments may not provide, but it does do that sort of functionality. And then we get enclaves, and some enclaves are fundamentally really close to TEs in what they are doing. Those enclaves might not want to follow the GP standard because they are following internal proprietary standards. That's fine. The point of following the GP standard is to enable more generalized use and to provide confidence in the um, the markets that you have created something which has standardized functionality and meets certain security standards. So if you don't need those particular rubber stamps your environment, then feel free to do something slightly different. But if you the way GP is looking, we will maybe in some of those cases, well, not necessarily the specific ones of TCG, but in some other areas for some other organizations, start to look at providing some certification if they wish, which would cover providing their functionality, maybe their attestation inside the GP environment. And so the TE committee is interacting with various external organizations to see whether things that today we would expect third parties to write a trusted application to implement would be of interest to come under the GP standardization in some manner. And that could just be that GP create some protection profiles so that a lab can then provide a security certification that the TE is secure and that particular trusted application executing on that TE is secure. Those sort of things can be done, and that's an area that we're looking to moving into the future to try and help the members of GP with their particular needs. And secondly, as I said, there is an ongoing future development program for what the underlying TE might provide. And so things like threading and other functionality that isn't available today is in that sort of future roadmap. And so those extensions will start to appear as we go forward. Well, I said those extensions will start to appear as we go forward. Let's just be clear. It's up to the members to donate material and provide resource and attend the meetings. And if they want a particular set of functionality, then they have to be present to try and drive that. If you are listening to this and thinking, but GP TEs have nothing to do with what I think of as a TE, then go ask your GP representative. Why not? And if you don't have a GP representative who's not actively on the committee, maybe that's why your concept of a TE doesn't match what the committee has created as a concept of a TE. So if you want to be involved, shameless plug, there is a email address there for getting in touch with GP if you can't find out who your current GP representative is. So I hope that was useful. I've tried to give a little bit of background history on where the GPTE came from, starting out with Nokia looking for a isolated secure environment that was generic and they could stick on all their phones, whether it was their top-end smartphones or their bottom-end feature phones. And then the hardware capabilities coming out of companies like ARM, looking at trying to solve that problem for the likes of Nokia in as cost-effective a manner as possible. The take up by the mobile network operators, looking to take advantage of this new technology and seeing the usefulness of having something that was standardized in both functionality and security terms to provide the isolation and capabilities they need across numerous platforms. And then how GP have taken that basic set of requests initially from the OMTP and then later from their membership and created a suite of documents defining what functionality you can expect to find in a TE and what security a TE shall provide, and defining it in such a way that third-party labs will then be able to look at those, go away and provide a assertion that a particular device or a particular piece of software meets that capability. So I hope that was useful for everybody, and thank you for listening.